Hello, Y12s. We are going to focus on the 2022 paper, question 3. We are working on questions II and then question III. These are both excellence level questions. So let us start with II. So just a quick little tip. If you see II, it's connected to the previous question. So we might need to go back for some information. So if you're a little bit confused of where I'm getting that from, it is just from potentially from the previous question. Okay, so let me hop in here. So it's a little bit bigger for me. Okay, so question II is, let me get rid of this quickly because you don't need that. There we go. Okay, question II says, the teacher also found that the probability that a student saved water was 2 times greater if they were concerned about water shortages than if they were not. The probability that a student saved water was the same, whether they were concerned about climate change or not. And the overall probability that a student in the survey saved water was 0.5632. Find the probability that a student is not concerned about climate change, is not concerned about water shortages, and does not try to save water. Now, the little hint that I know this is an algebraic tree is 2 times greater. And they're giving me an overall probability for something that's going on in the tree. Okay, so that's my hint that there's going to be some kind of missing piece in my tree that I'm going to have to use like a letter to fill. So let's just start this off. I'm going to work backwards because that's just how my brain works. But if I read from the top, okay, so they're talking about a student saving water. So I'm immediately going to start with saving water. Okay. I'm going to do that over there. Okay. And they're saying that the probability that a student saved water was 2 times greater if they were concerned about water shortages. So we've got saving water and then we've got concerned about water shortages. Okay. So as soon as I see 2 times, I know that's going to be 2 times something. So if you think about this logically, if I had $3 and Rebecca had 2 times the amount of money I have, we would just go 2 times 3, right? And that would give us 6. Now, the only issue is we don't know what she's 2 times greater than. So let's read on, okay? So they're saying that this probability that a student saved water is 2 times greater if they were concerned about water than if they were not. So we're going to have concerned about water, and then we're going to have not concerned about water because they're talking about if they were not concerned about water. Okay? So they're saying that the probability that a student saves water, so this amount here, is going to be 2 times greater if they were concerned about water shortages than if they were not concerned. So whatever this amount is, this is going to be 2 times greater than that. So we have save water here. Okay. Now we don't know what this amount is. They don't give us an amount. Okay. So we've got to figure out what we're going to put in place. So in maths, if we don't know what something is, we usually use a letter. Okay. So I'm going to use the letter X. Okay, and I'm going to read it one more time. The probability that a student saved water was 2 times greater if they were concerned about water shortages than if they were not. So this is going to be 2 times whatever this is. So 2 times x, which we can just write as 2x. Okay, so that's how I get to that. Now, we're either going to be saving water or we're not saving water. Not save water. Save water. not save water. Okay, so we've done the first little bit. Let's go ahead and move to the second bullet point. It says, the probability that a student saved water, okay, so the probability that a student saved water was the same whether they were concerned about climate change or not. Okay, so we've got concerned about water. We don't have concern about climate change, which means I've got to go a step further back and I've got to do concerned about climate change. So here we're concerned about climate change. Then we're going to have not concerned about climate change. Okay, boom, boom. So they're saying the probability of a student saving water, so these two are the same whether they were concerned about climate change or not. Okay, so doesn't make a difference. So we're going to have, then once again, we're going to have concerned about water shortages. Then we're going to have not concerned. Concerned about water shortages. And then we're saying the probability is going to be the same for saving water. So if this is 2x, this is going to be 2x, because they said it doesn't make a difference whether they care about climate change or not. The probability of them saving water is going to remain the same. So we're going to do this over here. So we're going to have save. We're going to have not save. Save water. Okay, so concerned about water was 2x. Not concerned was x. And they say the probability of saving water is the exact same. Okay, so we've done the second bullet point. Now, the third bullet point is saying the overall probability that a student in the survey saved water. So overall probability. So that means I'm going to be adding a bunch of goodies together. So the overall probability of a student saving water is 0.5632. Okay, so the probability of a student saving water is going to be 0.5632. Okay, now where are we saving water? Well, we're saving water up here, saving water over there, saving water over there, and we're saving water over there. Now, I still have some information missing from my tree, and this is where I do need to go back to my previous tree from question B-ii, and we can fill in that climate change was 0.7, 0.3, we've got 0.85, 0.15, 0.55, 0.45. Now, I've still got something missing here. This is missing, that is missing, that is missing, and that is missing. And now, our previous knowledge, we know that this has to add up to 1, that has to add up to 1, that needs to add up to 1, this needs to add up to 1. So when something is missing here, we'll usually go 1 minus 0.7, and that'll give us our 0.3. Often this is done in our heads. We generally know it, okay, because we know that 0.7 plus 0.3 will give us 1. We just know that, just from previous knowledge and growing up with maths and decimals. We know that by now. But perhaps we need to figure out a way, how can I use this, what I've just done, to fill this in? So let's say this was, like, just to say, for argument's sake, let's say this was 0.5. Okay? We would say that this would be 1 minus 0.5. And we would come up with 0.5. The only issue is this is not 0.5. This is 2x. And we don't have anything else to put here besides 2x. So we know that whatever this is, it's going to be 1 minus our 2x. Okay? We know that whatever this is, this has to add up to 1. So this is going to be 1 minus whatever that is, which is going to be x. And the same is going to be put down here. The same is going to be put over here. Okay. So there we've got our tree complete. Now, they're asking us to find the probability that a student is not concerned about climate change. So not concerned about climate change, not concerned about water shortages, and does not try and save water. Now, the issue with this is, do you notice we've got a letter? So we know it's going to be this multiplied by this, multiplied by this. We can't do anything until we know what this letter is. So that is what our job is. This is what we've got to do now. And we've got to use this amount they've given us to figure it out. Okay? So we know that the probability of this plus the probability of this plus the probability of this plus the probability of this will equal that. So let's just write it down. Okay? Let's work with this first one. How do we work out this probability? Oh yeah, we multiply along the branches. So let's write that out. We have got 0.7 multiplied by 0.85 multiplied by 2x. Just writing down everything that's on that branch. Check. Now I've got to add on what's my next one. We're going to work out the probability of this one, which is going to be 0.7 multiplied by 0.15 multiplied by x. Close bracket. Check. Done that one. Now we've got to do this one over here, which is going to be 0.3 times 0.55 times 2x. Check. I've done that one. Next one, I've got to do this one, which is going to be 0.3 times 0.45 times x. Perfect. I've done all four. And what is all this equal to? Well, they told us the overall probability that a student in the survey saves water, so that plus that plus that plus that is going to equal to 0.5632. So this equals, I'm going to have to write it very small, or potentially I'm going to write it a little bit skew, 0.5632. So all of this has to give me that. Now, if you grab your graphics calculator and you go to your solver and you put this whole equation in, you are going to get an answer for x. If you need to know how to do that, I've posted another video and it uses this exact equation and it shows you how to put it into the calculator. So if you need to go look at that, go look at that again. That will be, I'll add it as a link here somewhere. But our answer for x is going to be 0.32. Now, even if you're struggling with putting this together, if you just use some sort of x and you can at least try find this probability out, you might still get some marks because you're carrying on, like they will carry on marking with your mistake. You just won't get the full excellence, okay? And I'll actually show you I'll show you the schedule in a second. But they want to know the probability, so let me grab my highlighter quickly. The probability that someone is not concerned about climate change, is not concerned about water shortages, and does not save water. They want this probability, okay? So let's go ahead and work it out. We know that it's that times that times that, so just pop it down. 0.3 multiplied by 0.45 multiplied by 1 minus x. Now, we do know what x is over here. So again, if you're struggling, just write down x equals something, okay? Make sure it's obviously smaller than 1 because we know that all of these have to add up to 1. So what I'm going to do is I'm just going to take out whatever x is. So I'm going to take out that x, remove it, and I'm just going to put in whatever my answer was, which was 0.32. Nice. And if I put that into my calculator, I'm going to get the following. 0.3 times 0.45 times, and then I'm going to put my bracket in, 1 minus 0.32, close bracket, equals. So I get 0.0918. Okay, perfect. So that is my answer. That is the excellence. Okay, now if I can just maybe share the screen with you for the schedule. Let me see if I can do this quickly. Just switch it over to a different screen. Let's just do this screen, the one I'm currently on. Let's get rid of this quickly. Let's get rid of that. Oh, hello. Let's get rid of that. And let's do this one over here. Okay, and I'm hoping that when I open this up, over here, it's going to work. Okay, so if I have a look here, so here they figured out that x was 0.32. They plugged it in exactly like we did, and they got 0.0918. So we got that right. Now, incorrect x value found from correct process with a minor misconception. So, for example, maybe you only did one of the branches, or so you could still come up with an x here, even if you make some sort of mistake. You could still get a merit. You'll get an excellence for the correct x value found with valid working. Okay, so this equation and that final answer is fine. And then you'll get it for getting that answer correct. So I reckon that's a really nice excellence. I think the trickiest part is just understanding the tree and drawing the tree. So with that being said, I reckon we can move on to our next excellence question, which is going to be III. And III is asking us to use both of our previous trees to come up with some sort of claim. So let me just add in my camera again. Video add. Okay, there we go. So if I go down here, let's read the question. Okay, we've done that. Okay, now they're saying the teacher used both findings of both surveys from part A and B on the previous pages to claim. Okay, there's your little hint, claim. This is relative risk, okay? We're going to be comparing two things. They claim that New Zealand's secondary schools are 25% less likely to save water in their homes than the general population. Okay, so they are interested in comparing students to the general population and saving water in their homes. Okay, and we need to discuss the validity of this claim, use relevant calculations and statistical considerations to support your answer. Okay, so let's first get the calculations out of the way. So here I've got my previous tree from question II. Okay, and then I've also got my other tree over here from question I. Okay, so I've got two different trees here. We've got to use both of them. So let's first see what they're talking about. So we're saving water. Let's first start with secondary students, I guess. Let's just do that first. So secondary students saving water is going to be here. Saving water, saving water, saving water, saving water. And I don't know if you can remember, but they actually gave this answer to us already, which is nice. Okay, so they've already given us this answer. So this should just be, what did they give us? 0.5632. They gave that to us already. That's given. Okay, so let me go ahead. I'm actually going to do this just below here. Okay, So we're on question I. So we're worried about NZ schools at the moment, NZ schools, and how they save water. So the probability that an NZ school saves water, they gave it to us, okay, and that is going to be 0.5632. So even if you didn't do this whole tree, you could still just go and grab that information about the probability that that they saved water, and that's going to be 0.5632. Okay, so we are done with this group, I think. So we are done with NZ schools and them saving water. Now, let us move to the first probability tree, which was about the general population. So let me go and grab that tree here. Sorry, it wasn't this one. It was this one over here. Here we go. So they're interested in them saving water. So if you have to have a look, they are saving water over here. They are saving water over here. They're not saving water there. They're saving water here. They're saving water here. Okay? Even though it says they only save when restrictions, they're just asking about saving water, right? So let me go ahead and I'll take actually a quick little photo so it's easier for me than going back and forth between the two. Okay, let me take a photo of the tree. Done. Okay, so if we go back to the working out over here, okay, we have NZ schools, amazing. We now need to do the general population. So general population. So what's the probability? I'm just going to say general saves water. Okay. Now, if we look at our tree, okay, they saved water over here. So we know that's going to be 0.87 multiplied by 0.8 plus. So we've done that one. Check. What's the next one? 0.87 multiplied by 0.18. Perfect. Plus, I'm going to continue it down over here. So we've done those two. Amazing. Let's move on. Okay, we are saving water here. So we're going to do 0.13 multiplied by 0.5 plus 0.13 multiplied by 0.25. Okay, so that should be the general population saving water. So let us quickly have a look that I'm 100% right here because I'm just quickly checking at the checking 0%. Yeah, perfect. Okay, I'm matching with the schedule just before I go down the wrong path. Okay, so let's add this all together. Let me actually grab my calculator and share this calculator with you so you can see what I'm doing. Share. Okay. Let me clear this up. So I just want my normal calculator. So we have got bracket 0.87 times 0.8 close bracket plus open bracket 0.87 times 0.18 close bracket plus 0.13 times 0.5 close bracket plus open bracket 0.13 0.13 multiplied by, I made a mistake here, hold on, gotta quickly just delete that and pop in the proper bracket. There we go. Okay, 0.13 times by 0.25, close bracket. And that should equal 0.9501. Okay, perfect. Awesome. Now, we know that when they're asking us to compare two things, we're going to be doing one divided by other one. So they're mentioning secondary school students first. So we're going to take that amount, 0.5632. We're going to divide it by that amount, 0.9501. Okay? And when you pop that into your calculator, you should get, let me do it in mine. We've got 0.5632 divided by 0.9501. Okay, so my answer is 0.592779. Okay, and it just kind of keeps going. We know we want 4 decimal places. Let me count 1, 2, 3, 4. That number is 5 and above. Yes, that goes up by 1. So it's going to equal 0.5928. Okay, so that is the relative risk. That's our answer. Now, we need to really understand what this number means. Okay, so what this number means is it means that the probability of a student saving water is this many times as likely to this. Okay, so New Zealand schools are 0.5928 times as likely to the general population. Okay, now if we have to think, remember they gave us in a percentage, they said 25% less likely to save water. So if we have to look at this as out of 100, okay, so 100% would be 1.0, right? Or if you want, you can actually just pop this into a percentage. So if we wanted to do that, we could go, just make sure that I'm in your screen here. Yeah, okay. What we could do is we could go 0.5928 and we could just multiply that by 100 and that would give you 59.27%, basically 28%. Okay. Now, what you need to understand is that if this number was the same as this number, okay, it would be like 1 over 1, which would give us 1.0, okay, which means that they're the same amount as likely as this, right? But now, if you look at this number, this is out of 100. This is 40% less likely than that, okay? So if we, like, just from looking at this number, I can go, 100 is roughly 60%. So I would say that New Zealand schools are actually 40% less likely compared to this, compared to general population. Okay. So I would not agree with what they're saying because they said that school students are 25% less likely. Okay. 25% less likely. So 25% less than 100 would have given us what? 75%? We didn't get 75%. We got around about 60%. Okay. So they're even more less likely. So what I would write down here is I would say the probability of a student saving water is 0.5928 times as likely. Okay, now, again, if we're just looking at this number, we know that if this number was to be a 1, the likelihood would be the same. Okay. But because this is less than 1, it means that the whatever the number at the top is, the numerator, that one is less likely. Okay. If this was like a 1.5, it means it would be 1.5 times more likely. But because it's less than 1, it's less likely. Okay. It's lower. So less likely, then I would add in here, which is 40%, because they gave it to me in a percentage. So for me to get to 100 from here, I would need to add on 40, right? Or 0.4, 40%. Okay, so that's how short I am. So I'm 40% less likely than the probability of the general NZ population. I'm running out of space. Then I would say the claim is not valid. So that's one part. Then you still need to talk about the validity of the claim, and using statistical considerations to support your answer. So what I would go and talk about is pretty much questioning the validity. So we could say something along the lines of, well, the second survey only surveyed students from 2 schools. Because if we went back, so when you're talking about validity of claims, go back and read the questions. And if we have a look at it, it says she surveyed 200 students from United 13s at 2 local high schools. Now, statistically speaking, you know that this is not exactly great for statistics. So talk about how she only surveyed people from 2 schools. So it definitely does not represent all New Zealand students. So students living in different areas could have different, opinions and actions about saving water. Then another one you could talk about is the difference in how people who save water were categorized, making the comparison of the surveys difficult. Okay, and then you could also say that an online survey could be biased. So you could come up with a couple of reasons. My favorite one is the first one because it's the most logical, but that's just me. And from what I understand from the schedule, if you have a clear discussion about the validity of the claim and you got the correct relative risk, which was that, you would get your excellence. Okay, so there is the relative risk. There is the statement about it. Okay, and then I would still need to discuss the validity. So I would talk about it's only 200 students. It's only from 2 local high schools. Perhaps somebody, in a rural area would have a different opinion about saving versus somebody in the city. And then also it is tricky with how if you look at the general population and how they did how they separated them, it's quite difficult to, I guess, really compare. Yeah, it's difficult to compare because of just how they're categorized. It's a little bit trickier. It's not as straightforward. So yeah, anyways, hope that helps.